Look around any big city. What do you see? Glass, steel, concrete, reaching for the clouds. For over a century, build higher. We got pretty good at it. We stacked floors on top of floors, creating monuments to human ambition that pierce the skyline. It's a simple, elegant solution. Or it was. Every good idea has a limit. We're starting to hit ours. The sky isn't as limitless as we thought. The more we build up, the more we deal with wind, shadows, and sky-high land prices. People won't stop moving to cities, hubs of innovation, culture, opportunity. More people flock here every day. The squeeze is on. We're packing more into the same spaces. Make apartments smaller, make buildings taller, but eventually you hit a wall. A ceiling. Engineering challenges get extreme, costs become astronomical. The city below suffers. Whole neighborhoods cast in shadow. We've spent generations looking up. Maybe we've been looking the wrong way. What happens when you can't build higher? When the only way is no longer up? You get creative. Think outside the box, or inside the ground. Strange, yes. Our history is climbing out of caves, not building bigger ones. But necessity breeds invention. The answer: down. Alright, so what exactly is an Earthscraper? It's a simple name for a beautifully complex idea. You take a skyscraper with all its floors, offices, apartments, and shops, and you flip it. You invert it. Instead of building 100 stories into the air, you dig 100 stories into the ground. It's a building in reverse, a void that becomes a destination. Not just a basement or a parking garage, it's a self-contained vertical city plunging deep into the Earth's crust. A traditional skyscraper says, "Look at me." An Earthscraper is the opposite. It's discreet. From the street, you might only see a massive glass-covered opening. It doesn't cast a shadow, it creates a courtyard. It doesn't block the view, it becomes the view. It's a fundamental shift. Instead of imposing a structure on the landscape, you are carving a community out of the landscape itself. Humble, yet audacious. This isn't a dark, damp hole. That's a bunker. An Earthscraper is designed for life, an architectural challenge of the highest order. The question isn't how do we fight gravity, but how do we bring light, air, water, and a sense of openness down with us? Light, air, water, a sense of openness, a new tool set, dirt under the fingernails engineering. You're not just building a structure, you're creating an ecosystem. Skyscrapers conquer the sky. Earthscrapers coexist with the earth. They work with the planet, not against it. The ground provides natural insulation, structural support, protection from the elements. Nestled in the planet's embrace. Radical, yes. Logical, absolutely. We've mastered building up. The next great frontier is digging down. So you've decided to build an Earthscraper. Great. Now what? First you need a hole. A very, very big hole. Digging a precise 1,000-foot deep chasm in the middle of a bustling city is not a weekend job with a shovel and a wheelbarrow. This is one of the dirtiest, most complex jobs imaginable. Excavation on a staggering scale. Remove millions of cubic tons of rock and soil, while ensuring the buildings next door don't slide into the abyss. It's messy, loud, difficult, heavy machinery, precision blasting, an army of hardworking people. Once the hole is dug, the real challenge begins, making it stable. You can't have sheer dirt walls going down 100 stories. You need a massive retaining structure, an inverted skeleton, slurry walls, secant piles. Crews create a super strong waterproof perimeter, like a dam, holding back the entire planet. This shell is the backbone, safe and dry for centuries. A dirty, concrete-heavy job nobody sees, everyone depends on. You don't build from the bottom up, you build from the top down. Floors assembled at surface, then lowered section by section like an assembly line, efficient, safer. Most work happens at the surface. Clever solutions for complex problems, elevators a quarter-mile straight down, ventilation shafts as lungs, plumbing against gravity, every system rethought. Building down is in many ways more intricate and a true dirty job, start to finish. Living underground sounds dark, doesn't it? Damp basements, windowless rooms, but a true Earthscraper is designed to be flooded with natural light. A massive open-air void at the core. Imagine a giant inverted pyramid open to the sky. A colossal light funnel wide at the surface, tapering as it descends. Atrium walls lined with windows of every apartment, office, and public space, each with a line of sight to the sky. But a big hole isn't enough for the 100th subfloor. Technology steps in with brilliant solutions, advanced fiber optics and strategically placed mirrors. A massive heliostat tracks the sun, reflecting a concentrated beam down the atrium. Secondary mirrors and light-conducting pipes channel sunlight to the lowest levels, real sunshine. 800 feet down, you might need sunglasses. Air quality matters, Earthscrapers breathe. The atrium drives natural ventilation via stack effect, fresh air drawn down through intakes. Advanced filtration keeps it fresher than the city above. a giant lung. It's a vertical ecosystem, cascading gardens. Every level with green space, plants, trees, even waterfalls. Not just for show. Purify air, regulate humidity, and reconnect us to nature. Wake on the 50th subfloor to a lush terrace and a framed sky. Bring the park with you no matter how deep you go. This isn't just a theoretical exercise, some of the world's most innovative minds are taking it seriously. Mexico City, dense, historic, the Zocalo is protected. In 2011, BNKR Arquitectura proposed the Earthscraper, a 65-story inverted pyramid beneath the plaza. Surface preserved via a massive glass floor skylight, homes, shops, a museum deep below. It solved a specific problem: grow the city and preserve its heart. A skylit city below the square. Homes, offices, cultural centers, gardens. Green spaces on every level. Unbuilt, but it sparked a global conversation. Singapore looks down too. Extensive underground infrastructure. The underground science city proposes labs and data centers below, freeing land for parks, housing, public amenities. A practical approach. Start with infrastructure and industry, then residential and commercial. These pioneers are tackling geology, engineering, economics, and human factors, layer by layer, from Mexico City to Singapore. This isn't a wild fantasy. It's an ambitious, practical response to a growing crisis. Folks willing to get their hands dirty and look straight down. It's incredibly difficult and expensive, so why bother? What's the payoff? First, space. Create millions of square feet out of solid earth. Increase density without a bigger footprint. Add housing, add commercial space, no new shadows, no blocked views. Preserve the skyline above, let the city grow below. Earthscrapers are more energy efficient. The surrounding earth is a massive insulator. Stable temperatures year-round, far less energy for heating in winter, cooling in summer. Skyscrapers get battered by sun, wind, freezing temps. Their HVAC runs overtime. Underground you're protected. Less energy means a smaller carbon footprint, and a more sustainable way to house many people. A green building, literally. Resilience. Virtually immune to hurricanes, tornadoes, high winds. Deep foundations provide stability against earthquakes. Seismic engineering still matters, but less vulnerability than tall, swaying towers. In an unpredictable climate, sheltered habitats are forward-thinking. A safe harbor in the storm. Finally, community central atrium, terraced levels, design that encourages interaction. Not isolated boxes, public spaces are visually connected. See activity, gardens, cafes, public squares, a shared vertical village that fosters connection. Let's not get carried away. Building a city underground isn't all sunshine and vertical gardens. There are huge, dirty, expensive hurdles. First, cost. Digging a skyscraper-sized hole and reinforcing it is astronomically expensive. Excavation, specialized machinery, mountains of concrete and steel. The initial investment likely dwarfs a comparable skyscraper. Then safety, fire 80 floors down, evacuating thousands up a 1,000-foot shaft, flooding, retaining wall failure. These are not small problems. Engineering must be flawless, redundancy upon redundancy. Massive, high-speed elevators for evacuation, the highest safety standards in history. And perhaps the biggest hurdle is us. Are we, a species of open plains, ready to live underground? Claustrophobia is real. Living with tons of earth overhead triggers primal fear. Even with light and atriums, convincing people to buy a 75th subfloor condo is a marketing challenge. We'd need a cultural shift. So the road is paved with money, safety, and psychology. Overcoming them requires more than clever engineering. It demands bold investors, visionary planners, and a public willing to trade a traditional view for a radical future. Dreaming is easy. The dirty work decides if Earthscrapers remain fantasy or become foundations. It's a tall order. Well, a deep one. What would it actually be like? Let's imagine a day. You wake up on subfloor 42. A gentle sunrise fills your room, mimicking dawn 500 feet above. Your window opens to a green terrace across a vast atrium. Waterfall past the public library on subfloor 50. A bright blue circle of real sky crowns the cone. It's quiet, no traffic, no sirens, just the building's soft breath. You walk to a cafe along a terrace, sit over the central void. The air smells of plants and clean filtration. A friend rides a local 10-floor elevator, there in a minute. The building is walkable and convenient. Your gym, your grocery, your workplace. Just a short elevator ride or a stroll through a vertical park away. You head to subfloor 80. The atrium narrows into an indoor park. Running tracks, sports fields, groves of trees, illuminated by powerful shafts of channeled sunlight. Kids play, joggers run. It feels like a normal park, except it's 1,000 feet underground and shielded from a storm soaking the city above. You live in a self-contained, well-managed biosphere. Evening falls, lights shift to warm twilight. The atrium becomes a canvas for projections. Dinner near the surface, city lights visible through the glass. Life here blends natural and artificial, futuristic and primal, structured, convenient, predictable, like a perfectly engineered human terrarium. It wouldn't be for everyone, but it's a compelling vision of an orderly future. Here we are at the bottom of the hole, looking up. Could these audacious structures really be our future? It's no longer just science fiction. The technology is plausible. The need is undeniable. The benefits are compelling. As cities swell, climate change worsens and resources grow scarce. The logic of building down is hard to ignore. Earthscrapers offer growth that's sustainable, resilient, and more in tune with the planet. Not the steel towers we celebrate. But let's be honest, we won't see a 100-story Earthscraper in Manhattan next year. The barriers are immense: cost, safety, and psychology. Progress will be slow and methodical. It starts small: underground infrastructure, data centers, a few brave commercial projects, the proving grounds to test engineering, refine safety, and shift perception. We need pioneers, visionary developers, and bold city governments. Engineers pushing excavation, material science, and life support systems. And we, the public, must open our minds, reconsider home, see beauty in subterranean gardens and logic in a sunlit atrium 1,000 feet deep, trade the penthouse view for a new perspective. The question isn't just can we do it, but should we? Is a controlled subterranean world the future we want? I don't have the answer. But I'm a practical guy. I look at overcrowding, climate change, and our need for space, and I see a simple, logical solution. We've run out of room going up. Maybe it's time to get our hands dirty, grab a shovel, and start looking down. The future of our cities might be right under our feet, waiting for the courage to start digging.